objects. So we'll write an arrangement, objects, people, whatever, where order doesn't matter. All that matters is what we get. It doesn't matter, maybe even arrangement is a bad word there. A set of objects where order doesn't matter. So a state's Department of Transportation plans to develop a new section of interstate highway, and they get 16 bids for the project. Bids are when companies are saying, you know, like, hey, we can build your project for this much money. And another company's like, oh yeah, well we can spend less than that. You can spend less on our company. Of course, the hard part there is deciding like whether a company is quality enough, because you don't want to go with necessarily the cheapest option because they're not going to get the job done the best. So, a state plans to hire 4 of the bidding companies. How many different combinations of the 4 companies can be selected from the 16 bidding companies? It doesn't matter the order in which they get these companies. All that matters is who they pick to do the project. So there are 16 choices here, and we're going to choose, that's a combination, 4 of them. Now, the combination formula is n factorial divided by r factorial and then n minus r factorial. This is the one that I was trying to do earlier accidentally, and that is equal to n choose r, or n combination r. So if I wanted to do this in my calculator, I would put 16 factorial on the top. On the bottom would be 4 factorial and 12 factorial. So it's like we're dividing by something a little extra here. You can also use a combination key on your calculator. So 2 different ways to do this one. So first I'm going to try the long way. That's the factorial way. Divided by parentheses 4 math times, what was it, 12? Okay, and that makes 1,020, 1,820. But also, if I use my calculator and I type in 16 math probability down to combination instead, and pick 16 combination 4, I also get 1,820. So either way works. These formulas, you might think, why would I ever use that formula if I know this? And that's because sometimes they'll ask you questions about stuff like that on the AP exam to see if you understand the formulas. So, just in case. Remember, we'll practice this stuff a lot, but this is the stuff from Intro to Stats. It's important to know it. Find the probability of being dealt 5 diamonds from a standard deck of 52 playing cards. Okay, so it's a probability, so it's going to be a fraction. On the bottom, we're picking 5 cards, and when you play any kind of game, it doesn't matter what order you get the cards in. It's not like if I was looking for a straight and I got like a ace, 1, 2, 4, 3, I'd be like, oh no, they're out of order. I wish I had gotten that 3 before I got that 4. If they're in your hand, you can rearrange them any way you want. So on the bottom are our total choices for picking 5 cards, which is 52 choose 5. That's the total possibilities of different hands you could get. Now on the top is what we want, and that's 5 diamonds. And there are 13 diamonds in the deck, and again, it's a combination. We're picking 5 of them. So it's a fraction over a fraction. So you got to do both in your calculator. And again, it's a combination because it doesn't matter what order you get them in. You can pick any order you want. 13 choose 5 and 52 choose 5. So it's 1,287 out of 250, or 2,558,960. And then if I actually divide those two, See how it says 4.95 e to the negative fourth? That means you move the decimal place to the left 4 times. So that's 0.000 495. Again, we're going for 3 significant digits there. Okay. So if you are playing cards with somebody and you happen to draw 5 diamonds in a row, the chances of you doing that is 0.04% or 0.000495. A food manufacturer is analyzing a sample of 400 corn kernels for the presence of a toxin. In this sample, 3 kernels have a dangerously high levels. 4 kernels are randomly chosen from the sample. What are the chances you'll get exactly 1 toxic kernel? Okay. So we have 3 that are dangerous and 4 are randomly chosen from the sample. What are the chances you'll get exactly 1 toxic kernel? All right, so out of my choices, I have 400 corn kernels, and I don't care the and if you're like, why would I care about this? This is like super important in like farming and stuff like that because, somebody will say, oh, well, you just happened to pick a bad kernel, and the truth is that the possibility of them picking one is very, very hard to get. So we'll see that. 400, and we're picking 4 kernels. So that's all the different combinations of kernels I can get. And then there are exactly one toxic kernel. That means that I need to get 3 non-toxic kernels and 1 toxic one. So let's talk about the toxic one first. There are 3 toxic kernels to choose from, and I need 1 of them times. There are 397 good kernels. These are the good ones. And I need 3 of those. So 1 toxic and 3 good kernels, total of 4. And then I multiply it all out. Anything, by the way, combination by itself, 1 is that thing. So 3, math, combination 1 is already 3. The other one was 397, choose 3. The top here is 3 times 10 million. And the bottom is 400, choose 4, which is a super high number. And I multiply the top